rational expressions. This video will introduce us to rational expressions, and rational expression is a fancy term for fraction. And when you have fractions, you may have trouble, especially if you have variables in the denominator. So as we get introduced to these, we will also talk about the restrictions. So this is our rational expressions restrictions video. A rational expression is a fraction where both the numerator and denominator are polynomial expressions. When you have rational expressions, you always need to remember that there are restrictions if there are any x's variables in the denominator or the bottom. Reminder, you cannot divide by 0, which means undefined. Hence, we have restrictions. So any value of x, or any variable if it's not x, that makes the denominator 0 is a restriction. Okay, it's an excluded value. If you are given a rational expression, you must always find the restrictions before you simplify. Okay, that also extends to like add, subtract, multiply, and divide. So before you do anything to the stuff, find the restrictions first. All right. So here, find all the numbers that make the denominator 0. That is, find all the restrictions. And I have a place over here for you to... I have the wrong thing selected. I do that just about every time. All right. I have a place over here for restrictions, right? Put those in there. And then when you get your answer, when you get your this thing simplified, you put it in the box here. Okay, that's where I'm headed with all this. All right. So then simplify. That's the thing that I have over there. So how do I find my restrictions? I take the denominator not equal to 0. Okay. So x minus 1 not equal to 0. And the only reason I put not equal to is because it's a denominator. I'm reminding myself that it's a restricted value. It's the same thing as equals, just with a slash through it. Solve it the same way. So x cannot equal 1. So I already have the x not equals here, so then the only thing we put in here is 1. You may get a list of restricted values. If you have a bunch of things that you found that make the denominator 0, like 7 numbers, you would have all 7 of those as restricted values. All right, so x over x minus 1. Let's go back now and simplify this. Can I do anything to this? Well, the first thing you do is you factor either one of these. Do either one of those factor? Nope. Well, since they don't factor, then we see, can we divide anything out? Can I divide these x's out? I hope you say no, because if I have a string of terms, which means 2 or more terms, here's 2 terms. That's a binomial, right? I can never, ever, ever take one term here and one term here and cross those out. Cannot do that. Cannot do that. So this thing is already in simplest form. Already, I know my handwriting is great. Already in, I can't even spell. Let me try this again. Already in simplest form, okay? So if I were to simplify it, I can just say it's x over x minus 1, or maybe your teacher wants you already in simplest form. I think the book that I currently teach out of says that. Already in simplest form, but it's x over x minus 1. You cannot do anything else to that. Now, let me say one piece to this. If that thing factored and nothing divided out, I personally would want you to leave it factored, because that tells me, hey, I know nothing else divides out. All right, so the next one, I take simply the denominator. When I'm talking about restrictions, I don't care. The top could be Mickey Mouse, Minnie Mouse, it could be baseball, it could be a Mack truck, it could be whatever. I don't care. For restrictions, I take the denominator and I say, hey, that denominator can't be 0. So in this case, I have a quadratic, right, x squared. So then if I can factor it, that's my best choice to do this, unless I can't factor it. But if I can, so x and x, this is a list method. If you have trouble factoring, and by the way, you solve this the same way as if it were equals. If you have trouble factoring, watch my list method video for this one, because that's what this is. 3 terms, no GCF with a 1 in the front. That's what I call list method. So then here, factors of 8 that subtract to give me 2. Okay? So we have 1 and 8 and 2 and 4. Which one subtract to give me 2? And by the way, it doesn't have to factor, but this one does, 4 and 2. 4 minus 2 is 2. And I'm going to worry about the signs now. This says they're different. In my mind, I say that, but when I read it out loud, I go, the bigger number gets a plus. That's how I read it. The bigger number gets a plus. 4 gets the plus. And when I say the word bigger, I'm implying that they're different. So the 2 gets a minus. So here then, I need to take and separate these two things. X minus 2 is not 0, nor x plus 4 is not equal to 0. And then I solve each one of them. So x cannot be negative 4. I'm sorry. X cannot be negative 4, nor x cannot be what? 2. So x cannot be 2. So then we get 2 comma negative 4. And it doesn't matter the order. If your teacher says, hey, put them smallest to biggest, then you do what your teacher wants you to do. I don't care what order you put them in for me, for my students. All right? So here, can I factor this up here? Well, yeah, it's got a common factor. So I'm of 2, right? So I'm going to take a 2 out and I'm left with x minus 5, right? And then, look, I'm going to factor this, but didn't I already factor it right here? Don't double up your work, y'all. You already factored it. Say, oh, there's my factored form. Let's bring it over here. X minus 2 times what? X plus 4. I already factored it. Just go over there and pull it back across. Does anything divide out here? No. This 2 is one term. This 2 is part of 2 terms. That will not factor out. Do not do that. All right? So then x minus 5, there's nothing down here like it. So guess what? It stays. So I cannot do anything else. That's my final answer right there. Okay? So, and if your teacher wants you to distribute that 2 back out and FOIL the bottom, the denominator, then by all means you do that. Okay? I don't want you to do that, because if you give me this answer here, then I say, guess what? They know how to factor, and this basically screams, hey, nothing divides out. Nothing divides out at all. Okay? So let's look at some more of these with these restrictions. Okay, let's look at some more restrictions. So this one, again, denominator not equal to 0. Well, guess what? That's already factored. How glorious is that? That means I I have students all the time that go FOIL this out. Why? It's already factored for you. How do I know? Pluses and minuses are in parentheses. There's nothing between them, right? Pluses and minuses are in parentheses. There's no GCF. There's no power bigger than 1, right? This is the first power and the first power. That tells me I'm completely factored. There's nothing to do here but set these 2 things and solve. Not equal to 0 here. So, and then just solve each one of them. So x cannot be negative 7, and over here x cannot be 2. So 2 and negative 7 are my restricted values. So here I'm not solving, but later on, like with the way I teach it, I teach this at the beginning, and then at the end of the section, right before we test, we learn how to solve these equations. See, these are expressions. If you have an equal sign, if this said equals 1, that would be an equation because it has an equals. If it doesn't have an equals, it's an expression. This thing is called an expression. Notice we call this rational expressions and restrictions is what we're talking about here. So does anything divide out with the x plus 3? Nope, none of those divide out. So guess what? This thing is already in its simplest form. So I'm just going to write it down this way. And if your teacher, makes you do the other, then that's right. You'd write already. I'll try to redeem myself in simplest form. Okay? You didn't see me, but I was using all kind of Jedi mind tricks to write that where you could halfway read it. All right? So then y plus 5 over y squared minus 25. Here I have this fraction. All I care about is the denominator when I talk about the restrictions. So I'm going to come over here, y squared minus 25, and say it can't be 0. This one has a power bigger than 1, so that's why I try to factor it. It is 2 terms with no GCF, even power, a minus, and a perfect square. That says to me difference of squares. All right? Says to me difference of squares. So this is going to be 5 and 5, and this is going to be plus and minus. So then y plus 5 can't be 0, nor y minus 5 can't be 0. And so I'm going to subtract 5 here from both sides and get y can't be negative 5. And over here I'm going to add 5 to both sides, and y can't be 5. So I'm going to put in here plus or minus 5. You can write negative 5 comma 5. That's okay. All right? That's okay. I'm going to write plus or minus 5. That's the typical notation for math people. Again, we're called lazy sometimes, but I think that's efficient. You're only writing the 5 once. So that's plus or minus 5. But the only way you do that is if you get an actual negative 5 and a positive 5. You get plus or minus 5. So now I have my restrictions. Now I can go back and say, okay, how do I factor this thing? So y plus 5 over, well, we already have it factored. We already did it. Y plus 5 times y minus 5, right? We already factored it right here. So just bring that and put it over here. Why do it again? And remember, When you have a fraction written this way, this is understood in parentheses, this whole thing is, and the whole thing is understood to be in parentheses when it's written as a horizontal fraction line. So that means this whole thing is right here, so those things divide out. Now you got to be careful. I'm not just left with y minus 5 because y minus 5 is where? It's in the bottom or denominator. It's got to stay there. So if I divide everything out, this divides out, by the way. It doesn't cancel. It's 1, okay? And I know some of y'all are screaming. If you go look it up, if you look it up online, Merriam-Webster's dictionary, you look up the word cancel, it's going to tell you that dividing out common factors is that definition. That's because you know why? Math teachers like myself, math people, we lied to you so long that you just believed it, okay? We lied for so long you believed it. I don't have a book in my office that's newer than 30 years old, right, that has the word cancel in it for this. Can't find it. And I have a ton of math books in my office. Okay, so I was taught cancel. I'll still say it sometimes. Your teacher was taught cancel. And what we do as math teachers, we know how to do math. I mean, we studied math. We know how to do it. So then we don't look at the book. We don't see that the book doesn't say cancel. We just say what we were taught. But really, it doesn't cancel. It divides out. Okay, I'm not going to fight that battle too much. You can keep saying cancel. Your teacher can keep saying it. That's fine. It doesn't really cancel. All right, 1, because if it canceled, it would go to 0, but it goes to 1. So 1 over y minus 5. 1 over y minus 5. So this is the restrictions video. They can get more complicated than this, y'all. I'm just kind of giving you an intro here, and we'll have restrictions throughout. You know, anytime you deal with these rational expressions, restrictions are involved if there is a denominator that has a variable in it.